The discovery of the first antibiotic penicillin was made in 1928 by Alexander Fleming.
From then on, we used various antibiotics to kill various bacteria that causes diseases.
This time it was seen that some bacteria become resistant to certain antibiotics, and diseases can no longer be cured so easily.
We're students from PIPL Lyceum that is located in Lviv, Ukraine, and our goal for this investigation is to create an educational video about antibiotic resistance,
So that more people can be educated on this topic.
And we'll be closer to ensuring one of the 17 goals of sustainable development, which is
ensure healthy lives and promote well-being for all at all ages.
So, to test how antibiotics work, we decided to do an experiment to see their effect on bacteria from our hands. We actually used two kinds of different antibiotics, ampicillin and ceftriaxone, which we got specifically for scientific purposes. We soaked small paper circles in antibiotic solutions and prepared 4 Petri dishes, all coated in agar. The first 2 dishes were mine. I'm Marissa. I transferred bacteria from my unwashed hands onto both. Then I added ampicillin-soaked paper circles to one and ceftriaxone-soaked circles to the other. The other 2 dishes were my friend's, Katerina's. She did the exact same thing with her hands. A week later, we checked the results. Instead of bacteria, we mostly saw fungi growing. There were only a few bacterial colonies, or sometimes none at all. You can actually see this in the pictures. We circled the bacterial colonies to compare them better. We also had one Petri dish where the agar was a little bit damaged, so we used it as a control. And in that one, there was way more bacteria growing.
Using the STEM case from GIZMOS about evolution, we can understand better how bacteria evolve resistance to antibiotics and pass this ability to one another. In this case, we've got superbugs, which are the bacteria that can be killed with antibiotics. 2 patients were infected with it from touching raw uncooked chicken. The usual antibiotic did not work on them. The chicken in both cases came from Monita Farms. We ordered samples there. While waiting for them, we could see that the resistance to antibiotics of this bacteria has grown through the years. Using the samples we've got, we can test the percentage of bacteria's resistance to the antibiotics. As a result, we can see that 59% of bacteria are resistant to antibiotics. That is really high amount. At the end of this experiment, we can see that the resistance of this bacteria increased from 8 to 59% in 40 years.
After that, we can hypothesize the emergence of antibiotic resistance and test it using our knowledge of evolutionary process. This can be either gene flow from one bacterium to another, or genetic drift, or natural selection. At the end of the case study, we see that resistant bacteria that have developed a mechanism to adapt to antibiotics can survive best. So natural selection is the best answer to this problem. At the same time, bacteria can use gene flow to transfer the trait of antibiotic resistance from one individual to another within the same colony. In this way, more bacteria can survive the effects of antibiotics. We have to be careful with antibiotics for a couple of reasons. Antibiotics are not selective and kill all types of bacteria, both good and bad.
bacteria can develop a resistance to antibiotics and not be killed by them.
Bacteria can transfer the ability to be resistant to antibiotics from one to another.
We're positive that this video will be useful for expanding your knowledge on antibiotics and bacterial diseases.
And you will be using antibiotics with caution and knowledge of their possible effects.
We hope you enjoyed. Thank you for your attention.
Bye!